Hey, this is Dr. B, and let's take a look at some typical photoelectron spectroscopy problems. This is a topic that is included under the umbrella of advanced placement chemistry, for example, and it's a useful tool to learn. It reveals the Aufbau order. This element, for example, this is the photoelectron spectrum of a pure element, and I think it's going to be 1s2, 2s2. If that's 6, I would say that is neon. And it is. It follows the Aufbau order when it's idealized, which it normally is. Here's another question. For the photoelectron spectra of sodium and potassium, there's sodium there. Notice it's lower energy, and there's potassium, it's higher energy. Energy increases in that direction. Explain the difference in the binding energy observed. Why does it take more energy to rip off the 3s electrons from potassium than the sodium? Well, I think the answer is pretty straightforward. They're both in the same orbital, but potassium has far more protons, therefore higher binding energy, right? So it has a higher ionization energy because there's a greater nuclear charge. You have more protons. For the photoelectron spectra of phosphorus, which is here, and by the way, if you can see it, it's right there. Looks like atomic number 13, 12, no, 10, 11, 12, 13, 14, 15 for phosphorus, and 16 for sulfur. Why is the 2p peak for sulfur, which is right here, of higher energy, meaning it's to the left, than the 2p peak for phosphorus? Well, I think what's going on here is that we have higher nuclear charge on sulfur. There is a larger positive charge, so it takes more energy to rip away those 3p electrons from sulfur. And why is the 3p peak for sulfur further to the right than the 3p peak for phosphorus? That's a different question, and it's not much of a difference, but sulfur is to the right, a little bit lower energy. Phosphorus here, this is the 3p peak, it's a little bit, phosphorus is a little bit higher energy. And I think the reason is because if you have more electrons in the system, you're going to have more electron repulsion, which makes it easier to remove those electrons. Sulfur does have more electrons. It's what? 3p, 1, 2, 3, 4, whereas phosphorus is only 3p3. So you'll have more electron repulsion in sulfur, making it a little bit easier to take those electrons off. These are some typical photoelectron spectroscopy problems.